In nuclear physics, one of the things they're going for is nuclear fusion, in which they're trying to contain particles, or even particles and antiparticles in high energy physics experiments. And so to do that, they need a magnetic bottle of some sort. One way of making this magnetic bottle is having magnetic fields, do this sort of thing, and so the particles moving around will tend to bounce back and forth. But the problem is a few of them leak out the ends of the bottle, so it's not really a perfect containment. One possibility is to have like a donut shape, and then you have wires that run around your donut like this. Okay, and as the wires run around the donut, then they produce a magnetic field in here like that. And so what we want to do is figure out how strong is that magnetic field inside that donut. Technical term for donut is a toroid. Okay. And a little story behind that: when I was in graduate school, one of my office mates in graduate school was from another country, and he knew only the science words. And so a group of us had gone over to a grocery store near campus, and we were buying some snacks and things to go back to the office, and he was at the bakery counter, and I walked over to help him out because he was having difficulty ordering what he wanted, and he was telling the person behind the counter he wanted sucrose encrusted toroids. And the person behind the counter had no idea what he was asking for, and I had to translate. I said, he wants glazed donuts. And so, anyway, but it's kind of like me in French. I only know the science words in French, so I cannot order at a French restaurant, but I could read a paper about non-radial oscillations in white dwarf stars. All right, so what we're going to do here is the same basic sort of thing. We are going to say that we're going to imagine an Amperian loop that goes all the way around. So integral of B dot ds equals mu naught I enclosed. So this will be B, because if I stay a constant distance from the center, B's got to be constant. So that's just the integral ds equals mu naught I enclosed. So that's going to be B times 2 pi r equals mu naught I. Well, what's I enclosed? It depends on how many of these loops are. So it'll be n times I. Because if you go around 20 times, then there's 20 currents. If you go around 50 times, then there's 50 currents. So it depends solely on the number of times you go by. So that means that the magnetic field inside that donut is mu naught I times n divided by 2 pi r. And so there we have it. It has 1 over r dependence here. So unlike the magnetic field inside an actual solenoid, here the magnetic field strength does depend on how far you are from the center of the magnetic field. And so that would make for some funny looking orbits inside there of charged particles. They would not really be circular orbits, they'd be oblong sort of things, but it would still confine a particle inside there, so it would wander around inside the donut. And so that would give you more perfect confinement than a magnetic bottle that had leaky ends.